They didn't just build another humanoid robot, they built a factory worker that can pick up a single screw with metal fingers and then walk a production line like a human. By the end of this video, you'll understand how Germany's new Agile ONE robot could quietly rewrite how industrial work gets done, and why its brain lives inside a massive AI cloud built on thousands of Nvidia GPUs. And wait for the demo at the end, where this bright, cartoon-eyed machine calmly handles tools that most robots would fumble. Humanoid robots have been hyped for years, but most of them either live in research labs or in glossy concept videos that never touch real factory dust. Agile ONE is different because it's being built from day one for industrial jobs. Material handling, pick and place, machine tending, tool use, and fine manipulation on the actual production floor. And unlike many competitors, this robot is tied into a full physical AI ecosystem. Software, arms, hands, mobile robots, and a cloud AI stack, all designed to work as one intelligent production system. Micro-hook. Here's the part that surprised a lot of robotics people. This thing isn't being built in Shenzhen or Silicon Valley. It's going into full production in Bavaria. On November 19th, Munich-based Agile Robots officially unveiled Agile ONE, its first full-size humanoid robot for industry. It stands about 1.74 meters tall, weighs roughly 69 kilos, and can walk at around a brisk human pace while carrying loads up to 20 kilos. In other words, it's built to blend into human workflows. Tall enough and fast enough to move between stations, strong enough to move boxes and parts, but not a warehouse forklift replacement. From day one, Agile ONE is pitched for material gathering, transport, pick-and-place operations, machine tending, tool use, and the kind of careful manipulation that usually still needs a human on the line. Agile Robots says full-scale in-house production will begin in early 2026 at a new facility in Bavaria, keeping the entire hardware supply chain under its own roof. That's a quiet but important detail. If they can really manufacture at scale in Germany, with European standards and tight control, this becomes more than a demo robot. It becomes infrastructure. Micro-hook. But the real headline isn't the legs. It's the hands. Agile ONE's most distinctive feature is its dexterous hands, derived from the company's Agile Hand technology. Each hand has modular fingers with more than 20 joints in total, and fingertip plus force torque sensors at every joint, giving it extremely fine control over how hard it grips. In company demos, the robot calmly picks up tiny objects like individual screws, one of the hardest things to do reliably with a humanoid hand. That sensor stack lets Agile ONE switch between delicate and powerful grasps, from handling fragile parts to lifting heavier tools, without needing a human to hand-tune every movement. On the outside, the robot is deliberately bright and friendly, with colorful panels, responsive LED eyes, and a chest display that shows status information at a glance. It's covered in proximity sensors and designed as a collaborative robot, so it can work safely in close contact with humans and existing robotic systems. Think of it as a cross between an industrial cobot and a Pixar character, made to feel approachable but still very much a serious machine. So how does this thing actually think? Under the hood, Agile ONE runs on what the company calls a layered AI architecture, essentially a stack of different AI layers, each responsible for a different level of intelligence. At the top, there's strategic reasoning and task planning, deciding what needs to happen on the line, in what order, to complete a job. Below that, faster layers handle rapid responses and real-time adjustments when something changes, like a shifted part or a human walking into its path. And at the bottom, fine motor control layers translate those plans into smooth finger motions and stable footsteps, so the robot can actually execute the plan in the physical world. If you want an analogy, think of it like a human worker. Your brain decides pick up that tool and tighten those bolts. Your reflexes stop you when someone bumps you, and your muscles plus nerves handle the exact angle of your fingers. Agile Robot says the model behind this is trained on one of Europe's largest real-world industrial datasets, plus simulated and human-collected data. So the robot's skills are rooted in real factory work instead of just lab toys. Micro-hook. And here's where it gets wild, and its brain doesn't just live in the robot. To train and run these models at scale, Agile Robots is plugging into Deutsche Telekom's new industrial AI cloud, built together with Nvidia in German data centers. This cloud is being equipped with up to 10,000 Nvidia Blackwell-class GPUs, delivering on the order of half an exaflop of computing power, a huge chunk of Germany's total AI capacity. The idea is simple. Instead of every factory trying to build its own mini AI supercomputer, They tap into this shared AI factory to train robotics foundation models, run simulations, and deploy smarter robots on the floor. Agile Robots is one of the anchor customers, using this cloud to train its industrial AI models and generate simulated data that helps robots like Agile ONE handle edge cases before they ever see a real customer site. Because the infrastructure is based in Germany and designed around European data protection standards, it also gives manufacturers a way to adopt high-end AI while keeping sensitive production data inside European legal frameworks. So when Agile Robots talks about physical AI, they literally mean AI models in the cloud, shaping how a whole fleet of physical machines moves, grasps, and learns. Not just a single robot running a local script. Microhook. And that fleet is bigger than just one humanoid. Agile ONE is part of a broader ecosystem of robots already in the company's portfolio, including the Agile Hand, the FR3 Force-sensitive robotic arm, the Diana 7 arm, the Thor series, plus multiple autonomous mobile robots and guided vehicles. At the center is Agile Core, an AI-driven software platform that connects all of these systems so they can share data, coordinate tasks, and act like one intelligent production system, instead of a bunch of isolated machines. In practice, that means a mobile robot might bring pallets, fixed arms handle repetitive motions, and Agile ONE steps in where human-like dexterity or flexible tool use is needed, all orchestrated by the same AI brain. Early deployments are expected to focus on tasks like box and parts handling, machine loading, operating tools, and precise assembly steps where you still want something with roughly human shape and reach. If Agile ONE works as advertised, you could imagine a line where instead of re-engineering the whole conveyor every time a product changes, you retrain the humanoid and adjust the AI workflows. Far cheaper than rebuilding hardware. That's the bet Agile Robots is making, that applying physical AI across a whole production system can unlock a new level of efficiency and quality for their customers. Microhook. But with that power comes a very real set of risks and uncomfortable questions. Let's start with the obvious one. Jobs. If a humanoid can walk into an existing factory, use tools designed for humans, and pull double shifts without breaks, that has serious implications for manual and semi-skilled industrial work. Companies like Agile Robots frame this as augmentation. Robots taking over dangerous, dull, or highly repetitive tasks, while humans move into supervision, maintenance, and higher value roles. But the transition is rarely smooth, and it depends a lot on policy, retraining, and how fast these systems actually scale from pilot projects to thousands of units. There are also safety and reliability questions. Collaborative sensors and software limits reduce risk, but any bipedal robot moving through cluttered spaces needs rigorous testing to avoid accidents. On the AI side, training on large industrial datasets raises questions about who owns the resulting models and whether insights from one customer's data could benefit another. And at a deeper level, giving a fleet of physical machines access to cloud-scale AI means cybersecurity isn't just about data leaks anymore. It's about making sure nobody can hijack or disrupt the physical systems. So where does this all go? In the near term, expect Agile ONE to stay firmly focused on industrial customers. Factories, logistics centers, and production lines where its dexterity and human-compatible form are clear selling points. Over time, as the layered AI architecture matures and the industrial AI cloud spins up more powerful models, you could see these humanoids learning from each other. One robot discovering a better way to handle a tricky task, and that skill propagating across the whole fleet. If Agile Robots and its competitors succeed, the phrase industrial revolution might stop being a metaphor and start looking very literal again. Only this time, the engines of change walk on two legs, make eye contact, and ask for the next job. And the real question won't just be what can they do, but who decides what work should still be done by humans, even when a robot can? So, is Agile ONE the robot that finally makes humanoids boringly useful? Just another tool on the factory floor? Or is it the start of a much bigger shift toward cloud-trained, physically intelligent AI coworkers? What would you want a robot like this to do? And what jobs or decisions would you never hand over, no matter how capable the machine becomes? Let me know in the comments, and if you want to keep up with how AI is escaping the data center and walking into the real world, make sure you're subscribed for more deep dives like this one. That's it for this one. Thanks for watching. Don't forget to subscribe, and I'll see you in the next video.